Are you tired of long, boring, and slow tutorials? Well, you're in the right place. Because in the next 2 hours, I'm gonna teach you SolidWorks in a real-world practical workflow. So let's get started. This is the workflow that we generally follow most of the time, and this tutorial is based on it. Initial hand drawing. It is not mandatory to do this, but I highly recommend getting paper-friendly and sketching out the initial concept of your model before you start the CAD phase. Part design. When you run the SolidWorks, you face this window, and the first step is to model your parts. In the part design workspace, you have all the tools you need to create components. Assembly. If your model is a machine or any type of system including more than one part, then you can import the components one by one and assemble them together in the assembly workspace. Also, there are tools to create exploded views, animations, and simulate the motions of your system, which is useful for the development of design, presentations, and guidance for manufacturing. Technical drawing. After completing the design, we need to generate technical drawings to proceed with the manufacturing phase. Here, in the drawing workspace, we create blueprints with dimensions, tolerances, and all the required data needed for the machining and documenting of our work. Alright, when we open the SolidWorks, we face this window, and by clicking on the new icon here, we have options to create a new file. And here we select the part. Okay, here is the part design workspace. As a brief introduction, let me tell you a little bit about the UI here. Our tools are here on these tabs. We have everything we need. Here is the units that we are working with. I set them on the limiter grams second, but there are other options as well. This area is our design tree. Everything that we design will appear here step by step under this design tree. This is the origin of the coordinate system. These planes are geometric references, and before starting the design, I show you how to set some shortcut keys. We set some shortcut keys to speed up our design process. We go to Tools menu, Customize, and Keyboard. For the Save As, we have Ctrl-Shift-S. For Dimension tool, we need to add a shortcut key. You can search here for the desired command. For the Smart Dimension tool, I added Ctrl-D. You can select the command, click on the shortcut, and press your desired keys to be recorded as the shortcut keys. For the Smart Dimension, we set the Ctrl-D. SolidWorks record the keys in the order that you pushed them. And another one for the measurement tool, I added the Ctrl-M, and that's all. Okay, we need just those shortcut keys during this process. To rotate the view, zoom in and out, we have the scroll button of our mouse for zooming in and out. If I press Ctrl, press the scroll button, I can move the view around, and if I just press the scrolling button and move it around, I rotate the view and That's how we control the view inside the SolidWorks. And here we have some options to change the graphic that we see. If I disable everything, it's the lightest graphic process for your computer. You can change the scene. You can change the materials and colors. We discuss them later. And here select what is visible and what is hidden. Some different types of the style for the geometry. In this style, you can see the hidden edges behind the solid objects, or see everything in a wireframe style. And all the general views to look around the model. The section view that is useful to see what's inside the solid body. You can change it here by selecting different planes. And this one is new for me. I switched from the SolidWorks 2021 to 2025 version. This one is new. You select the cylinder and see from the center of axis of that cylinder. Okay, that is section view. You can press Ctrl 8. It goes to the closest normal view to the geometry. Press Ctrl 7, the isometric view, or select some specific face or plane. Then press Ctrl 8 again. You have the normal view to that specific face or plane. I start our example lesson by sketching on paper, just as I mentioned earlier. First, I draw the problem in 90-degree torque redirection device. I sketch the boundaries of the available space for the device and mark the positions of the input and output shafts along with their given dimensions. Then I complete the sketch with my solution, including the dimensions and positions to be used in the CAD process. Now I select the top plane, select sketch, and now I'm designing one sketch. And the sketch is gonna be added on the design tree here. I select the line tools, the center line, click on the origin. You see this little yellow icon near the mouse. It shows that the line is going to be created with a vertical mate. And if I turn the mouse here, it shows the angle. And if I move the mouse further, it will snap to the horizontal mate. Okay. I create the borders from the sketch that I designed on the paper. I select this line, press Ctrl, and select all the other lines as well. Now you see some options here that SolidWorks suggested for us. It's including some tools and dimension and some mates. I select the equal, make them equal together. Now they are all with the equal length. So if I press Ctrl D and select one of them and type one dimension of 120 and press enter, The sketch entirely is black. There is nothing blue anymore. This state called fully defined. That means there is nothing undefined on the sketch and everything has a mate or a dimension that completely defines its state. Again, I select the center line, click here and create two other lines. The sketch is under defined again because these lines are not defined completely and can be moved around freely. So I select them again and make these two equal as well. These two lines are the center line of the input and output shafts of our system. Based on what I designed on the paper, I now add a dimension here. It was 30. Okay. Now I add some simple lines. So right now we see something that appears on the sketch. This area has different color because it is a contour, and the contour is some area that is closed by some sketches. Actually, it's a closed loop with no gaps, and SolidWorks shows them with a different color. I press the escape button on the keyboard to exit the line command. Control D, and I select this line. I add 10 millimeters, again based on what I have on the paper. I select this one and this one, make them equal again. And now I go to Features, Extruded Boss or Base. Now SolidWorks is going to extrude the solid body out of those contours we have in this sketch. Here you can select various contours from one sketch. If you do not select a specific contour, SolidWorks select it by self. As we have just one contour here, SolidWorks just selected that one. And I add the 20 millimeters for the extrusion. Okay, until now we were sketching on default geometric reference from the part design workspace, the top plane I mean, but we can select any other flat face that we have to create a sketch on it. Select this face and click on the sketch. I select the center line again. When I get close to this edge, SolidWorks offers a suggestion to use this center point of this edge as a start point for the center line. That's what I'm going to use now. I click here and there is one another on the other side and the line is fully defined. I want to create a hole. I select the circle and the center of my circle will be coincident with this center line. So I know that it's in the center of this direction and have the same distance to this edge and this edge. Press escape, press Ctrl D. I add the diameter of 10 millimeters. Okay. And another dimension to position the circle, 30 millimeters. So far, I was drawing this sketch and directly went to the features and selected one command here. But I can exit the sketch and we have the sketch on the design tree. We have the previous sketch under the Boss Extrude command. We can make that visible and hide it again. This time I select the sketch from the design tree to show you that there is no difference and select the extruded cut. This time I'm removing the volume from solid body. Again, sketch plane, and here I select blind again. 20 millimeters is okay. Across the other side. Done. Let's rotate the model to create the other hole. Again, sketch center line here and here. Another 10 millimeter and same position. Exit sketch, select this sketch, extrude cut, 20 millimeters, okay. This is the main frame of the device I'm going to design. But let's add something else on the frame first. On the SolidWorks, if I click on the any edge on any solid body, right here, SolidWorks suggests the fillet and the chamfer command. I'm gonna add the chamfer here, 10 millimeters, 45-degree of angle. We have other options here as well. We discuss them later. It's a symmetrical chamfer and just needs 20 millimeters. And okay. For this edge, just as an example, I select the fillet this time. And on the fillet, we have other options and so many settings here. But just go with the fillet expert right now. Items to fillet, I select this edge again and add 20 as the radius of that fillet. Apply and exit. Now I save this file by pressing Ctrl S. I name this part as main frame and press save. Okay, we close this file and open another file to create another component. This time I select the right plane and go to sketch tool. I click here and create a center line again. I'm designing the input and output shafts. Escape. I can select this line and change it from the center line to a normal line. Just uncheck this box that says for construction. And you can bring it back or change another line to a center line just by clicking on this checkbox that says for construction. Okay, I add some dimensions. This time I use another command that creates cylindrical shapes, revolve us or base. The contour is recognized. I just need to select the axis of revolution. And I select this line, blind and full cylinder. Okay. I select this face to create another sketch on. This time I use a center rectangle on the origin. And I use this sketch to create another cut from cylinder. Now let me show you how to edit things here and correct my mistake. On this revolve command, I have a little mistake on the sketch. I select the sketch. It shows the dimensions. You don't need necessarily to edit the sketch by getting into the sketching space. You can just select the sketch and double click on any dimension. This dimension needs to be 20. You see these lights here. It says that something you have edited and you need to click the rebuild icon here to update the design. Now I can edit this feature. As you see, the dimensions of the sketch and the dimension of the feature is here. We select this and change it to 15. Okay, another rebuild. I select the front plane, creating another sketch, another center line for position. I create a circle here, add 3, and distance is 5. So I can use a thicker shaft inside of it. Another 5. I go to features, cut. This time I select through all, both. And as you see, the cut is going to both directions and through everything. And I add some tiny flits just for the beauty and looks on the component. I save this file as torque shaft. Okay, I close this and create another component. This time I select the midplane for the extrusion. That means that everything we add for the extrusion amount will be distributed equally on the both sides of the plane that we are sketching on that. That's our sketch, and everything we add will divide it by half and apply it for the both sides. And here on the right plane, I add another center line and another circle in the center of that center line. Just as the same as the previous one. And a little bit of fillets again. This one is called spider. Now we have some components and let's start the assembly. New and click on the assembly. I select the main frame, open, and if I click anywhere here, SolidWorks will fix this component in that position. I cannot move it anywhere else. I right click on the component in the design tree and make it float. Now it's free to move. because I want to position this component precisely based on the geometric references of the assembly coordinate system. I select the top plane of this file and top plane of the assembly workspace, make them coincident from these mates that SolidWorks suggested to me. I select the coincident. I click here on the zoom to fit to see where it is. Now this component has 2 degrees of freedom and still is movable on the top plane. So I select the right plane of the component and the right plane of the assembly workspace. Now it has just 1 degree of freedom to move, and let's fix that as well. Okay, we have the component fixed in the position, and now I add other components to the workspace just by dragging the file into the SolidWorks. I move my mouse on the component and right click on the component and move around my mouse to rotate the component. I select this face of the shaft and this face of the hole. And SolidWorks suggested me some mates to apply. I make them concentric. We fix the shaft inside the hole. And I select this face, rotate the view, and press Ctrl, select this face, and make them coincident. Now this shaft is free just to rotate and it's not going anywhere. I press Ctrl, click on the shaft, click again and drag it. Now I have copy of that component and add the same mates to position the shaft on my device. Okay, let's add the next component. So I select this face and this one, concentric again. Now I want to add another new mate. I select this face, this one, and this one. When we have 2 faces of one component and 2 faces of another component, we can adjust those components with this mate that says width. The spider went into the center of rotation on this torque shaft we have. I select this component and just remove it because I want to show you something else. If I select 2 components from the design tree and press Ctrl C and Ctrl V, I have those 2 components and the mates between them. See? So I just need to put this back again here. Now I need to add another shaft here to connect these together. I save the assembly. Okay, so how do I extract dimension from the system to create that shaft with the proper length that fits inside here? I open the frame and the initial sketch. I make it visible. Press Ctrl 8. Okay, not this side. This side. Ctrl 8 again and create another sketch on top of this surface. I change the display style to this option that shows the hidden edges behind the solid objects, like this. So this is the path of the shafts that transfers the torque. These two are equal with the dimension of 25, and I select the measure tool, Control M. Now I see the length of that shaft, but it's not simply 91.92. Here we can see that it has lots of decimals here that will create problems and errors in the further design and further in the assembly. So I select the center line again and create these two lines that define a triangle with exact dimensions with no decimals. I select these lines one by one, and one of the commands here is make block. Okay, I just created a block of sketch members. You see here we have a block. We can create so many blocks inside one sketch or move them around and use them as guides to transfer dimensions and entities from feature to feature, from component to component, and use those blocks as references to create other parts. So I select this block, press Ctrl C, exit the sketch, exit the file, and save these changes. Yes. Now I create another component. I select top plane, sketch, Control V, and I have that triangle here as a block, and I use it to create the shaft. Okay, we need to put this block here and adjust it on the origin. Okay, these two lines, make them perpendicular. It's fully defined now. Go to feature, revolve, and this is the axis of revolution. Okay, and I use the same method to cut some area around here. So the thickness of this shaft is wrong. Please let me correct it. Exit the sketch and rebuild anyway. That wasn't a problem. I cut this side, line 15. Okay. And I do something new here. I select this face and this face, go to features, reference geometry, and create a plane. As I selected two parallel faces, SolidWorks create a plane between those two faces right away. Now I select this cut and this plane and go to features, and here we have mirror. Just like that, we have that cut mirrored around this plane and have it on the other side. I hide this plane and save this file as 20 millimeter shaft. That's just a name. Okay, to create those holes, we can select this face and this one and create another plane, but let's just simply change the display style and create it on the face that we have. I select both of these circles and here the relations are available too. I select the equal. I add a dimension of 5 millimeters here, the distance of 5 millimeters here and here. Okay. And I use it as a cut again through all both. And the same fillet for the beauty. Okay, save again. Now I add it to the assembly. Select this hole to make it concentric with this spider shaft. Again, the same trick, same mate for planes and width. Okay. So we face this error that says the selected mate could not be successfully created. That's because this mate that we are creating is going to disagree with another mate that is already exists. So cancel and let's see what's the problem here. Okay, we extracted the dimensions for the shaft from this sketch block, but these points were the location of the rotation axis and I mistaked them for the overall length of the shaft. So by adding the first concentric mate, it wasn't possible anymore to align the other side of it. I corrected the length and problem is solved. Isn't that beautiful and fun? Let me remove these sketches from the view. And now we have the assembly. Save the build and save document. Okay. And to create a technical drawing from an assembly, we just go to File and select the Make Drawing from Assembly or Make Drawing from Part. It depends that you are in which workspace. I select A4 ISO or ISO, I don't know. We have various views from the assembly. I select the top, drag it here and just let it go. And By moving the mouse, we can have the other views as well to complete the three views of the technical drawing and additional views as well. To exit this, press Escape button on the keyboard or click here in the OK. So if I move the mother view, the child views are moving accordingly. And I select it here, change the scale, and we have some tools up here to create, for example, section view. You can change the direction of that here. Okay. And have that section view, for example, like this. I'm not going too deep in the details here. It's just an example to show you the workflow, not discussing everything in details. We will get to the details and deeper tutorial right after this example. Here in the annotation, for example, the smart dimensions, we have it here as well. Control D, the same. For example, this dimension, this diameter, it's smart, it does know that what are you selecting. It's simply just a length or a diameter or radius on some corner. Save it as SolidWorks drawing file format. And that's it. We just finished our first example to discuss the entire of the workflow by this example.